In Lesson 1, the child learned the algorithm, if you know the sum of a line except for one cell, you can figure out that cell. The goal of Lesson 2 is to expand this connection to 2 lines. The sum used as a clue can be expanded from a single-line sum to a 2-line or 3-line sum. Making the child discover this expansion on their own is the core task of Lesson 2. Look at the shapes and positions of the blocks and the sum clues. Find the box you can figure out first.
I can figure out 1,3 first.
Why is that?
Because there's only one number that can go in there.
Tell me your answer and add a because at the end.
1,3 is 1. Because the sum of column 3 is 6. And since the 2-box sum is 5, the remaining box is 6 minus 5 is 1.
Well done. I think there are other boxes we can figure out for the exact same reason.
3,1. It's 3. The sum of column 1 is 6. And if you subtract the 2-box sum of 3, 3 is left.
You can fill in 3,2 the same way, right?
Right? The sum of column 2 is 6. I subtract the 2-box sum of 5. And put the remaining 1 into 3,2.
Great job! What do the 3 boxes we just figured out, 1,3, 3,1, and 3,2, have in common?
That they only have one number?
That's what happens at the end. But why did they end up with only one number? That's what they have in common. Think back to your because parts.
Column 1 gave us the sum of 2 boxes. And it was the same for column 2 and column 3. So we figured out the one remaining box in that line.
Exactly. Can you put what they have in common into one sentence?
We knew the sum of the rest of the boxes in a line, except for that box.
Perfect. If you know the sum of the rest of the line except for one box, you can figure out that box. This problem is the core of Lesson 2. 1,3 is easily figured out using the Lesson 1 method. But 3,2 cannot be solved with just a single-line sum. Let the child naturally get stuck at 3,2. Getting stuck is the beginning of a new idea. Find a box with only one possible number in this problem, too.
I can find it easily now. It's row 1. Because they gave us the sum of the 2 boxes except for 1,3.
Tell me your answer and add a because.
1,3 is 3. Because the line sum is 6. And the 2-box sum inside it is 3. So 6 minus 3 is 3.
Good job! There is another box with only one possible number. Look for it.
I can't find any besides 1,3. There are no more places where they give us a 2-box sum in a single line.
We figured out 1,3 thanks to looking at the whole line it's in. But there's no rule that says you always have to look at just one line.
I don't know what you mean.
Think about it like this. If we want to know what you do at school, we can look at your class. Grade 1, room 2. But you are in your class, and you are also in Nari Elementary School, right? If we look wider at the whole school instead of just your class, we might find out you do something else really cool.
Inside Nari Elementary School. You mean putting together all the kids in other classes too? Not just grade 1 room 2.
That's right. If we just look at the one line of your class, we might not be able to tell if you are the school president or a library helper. But if we look at the whole Nari Elementary School, we can clearly see what important role you have in the whole school.
So you're saying I shouldn't just look at one line in this problem, but look wider?
Exactly.
But looking at more than one line is hard.
Wait, let's think about candy boxes. There are 6 candies in total inside 3 boxes. What do we need to know to figure out how many candies are in box 3?
We need to know how many candies are in the other 2 boxes. If we subtract that number from 6, we get the candies in box 3.
This time, let's stack 3 more boxes on top. 3 on the bottom, 3 on top, so 6 boxes in total. Again, what do we need to know to find out how many candies are in box 3? But I won't tell you how many candies are in box 1 and box 2.
Then how can I find out?
How many candies are in the 3 boxes on the bottom row?
6?
What about the 3 boxes on the top row?
That's 6 too.
Then, how many candies are there in all 6 boxes put together?
6 and 6, so 12.
We want to figure out how many candies are in box 3. What do we need to know?
We just need to know how many candies are in the other 5 boxes. Except for box 3.
We can just subtract that number from the total 12. Out of 6 candy boxes, if you know the sum of 5, you can find the remaining 1. Then where is the place that matches the 6 candy boxes in this problem?
If you put together the 3 boxes in column 1 and the 3 boxes in column 2, it makes 6 boxes. And we can figure out the sum of 5 of them.
Great find! What is the 5-box sum, and which box can we figure out with that?
The 5-box sum is 3 plus 7 is 10. With this, we can figure out 3, 2.
Good! Tell me the answer for 3, 2 and add a because.
3, 2 is 2. Because if you put column 1 and column 2 together, it's 6 and 6, which makes 12. And if you subtract the 5-box sum of 10, it's 2.
You did so well! Now let's compare 1, 3 and 3, 2. Can you find what they have in common and what's different?
For 1, 3, we know the sum of one line except for that box. For 3, 2, we know the sum of 2 lines except for that box.
Then what is the difference?
Whether we used one line or 2 lines.
And what do they have in common?
Whether it's one line or 2 lines. Since we know the sum of the remaining boxes except for that box, there is only one number left for that box.
If the child says this, they have reached the goal of today's lesson. This is the core principle of relational thinking. It is not about what is the number in this cell, but seeing how this cell is connected to others, and that the scope of this connection can expand from one line to 2 lines and even wider. To sum it up, as long as we can know the sum of the rest except for that box, it doesn't matter how many lines there are.
Right? I think it could be even more lines.
Yes. Today we expanded to 2 lines, but next time it could be even wider. Now, try to fill in the remaining boxes while making sure numbers don't overlap in the rows and columns. What is different today compared to our last lesson?
Last time we only looked at one line, but today we put 2 lines together to look at them.
But they still have something in common, right?
That if you know the sum of the rest except for that box, there's only one number left.